Right, in this video clip we're going to be looking at using a percentage multiplier method for approaching percentage change, whether it's a percentage increase or a percentage decrease. And while this isn't always necessary when it comes to percentage change, so if you're just increasing or decreasing something by a fixed percentage, it does become much more powerful when you're dealing with more complicated grade B type percentage questions. So it's definitely worth trying to fix in your mind this way of working. The key starting point is that in your mind you have to treat the original amount, the original quantity, as 100%. And then any increase, percentage increase onto that, rather than working out what the percentage of the quantity is and then adding that on, the way the multiplier works is we add the percentage on to the 100 and then work out the value, the value from there. So as I've said here in my example, if a quantity has been increased by 15%, that means the original amount, which is 100%, has also been increased by 15%. So you've got your original amount and an additional 15%. So you're working with 115%. And this often causes confusion with students because early on in school, when they first meet percentages, they're always told that the most you can have is 100%. But what we're saying here is your original amount is 100. So if you then increase it, you will end up with more than 100%. Another simplistic way of looking at it, which is helpful later on, is if we think of this process as a number machine. So if we're putting our original value into the number machine, we're multiplying it by 115%, and what comes out is the increased value. On your Casio calculator, we've already met this when we were looking at taxation. We've got a percentage button. So if you're on paper 2, where you're allowed to use a calculator, I would suggest you learn to use the percentage button so that you don't introduce any other mistakes into your percentage work. So the percentage button is above the open bracket, so you would press Shift, open bracket, and that will give you the percentage. So in order to increase £120 by 15%, what you would type into your calculator, we've already established that a percentage increase of 15% means you could be multiplying by 115%. So if we just write that down to get used to it, so the percent multiplier will be 100 plus 15 is 115%. So to increase that 120 on our calculator, we're going to do 120 multiplied by 115% and then press equals. Are we going to put that onto our calculator exactly as I've written it? So 120 multiplied by 115%. Press equals, and that's your answer. So we're increasing £120, so we'll have a pound symbol, 138. So just to emphasize that we could have done that probably a way that would be more, you'd be more familiar with from lower down school. We could have found 15% of 120 equals 18 and then added on the 120. So you'd end up at the same place. Now, in my view, this is a one-step line of maths because although I'm writing that down for the sake of the example, I would expect you to do that in your head. It's an increase of 15%, so it's going to be 115%, and that's just the line of maths that you'd be working with. So that's for increase. Same idea when it's decreased. If something has been decreased by a given percentage, the outcome is smaller than the original. So if we're reducing a quantity by 12%, the original, remember, is always 100. decreased by 12 means you're going to end up with 88% of what you started with. As a number machine, original value times 88% gives you the decreased value. So to decrease 245 kilograms by 12%, before I type it, let's get used to writing. So the percentage multiplier this time will be 100 less your 12% because it's a reduction. So that's 88%. So on our calculator, we're going to do 245 multiplied by 88%. £215.6. Now if that was money, we'd write it £215.60, but because it's kilos, we don't have to worry about the putting in a 0 for the second decimal place. So as far as learning is concerned, it's a relatively easy thing to learn. You're starting with 100% and you're adding your given percentage if it's an increase, subtracting it if it's a decrease. So let's take a look at a couple of past paper questions. So this is an OCW question, so you will earn 2 of those 6 marks for the way that you set out your work and consistent with your units. So Gemma bought a tablet last year for £240. She sold it to a friend after a year for 35% less than she paid for it. So it's a decrease. She sees a new tablet on sale for £365 with a special offer of 20% off. That's a decrease. It's going to cost less than that. Gemma decides to use the money she has from selling her old tablet towards buying this new one. How much extra will Gemma have to pay towards the new tablet using the special offer? So first of all, how much does she actually get from selling the original tablet? So that's the first line of maths, and because we're communicating, that we're going to explain what that is. Money she gets from selling equals. Now there I would just write my line of maths down, but just in case you're still a little bit wobbly with this percentage multiplier, what you could do in your head I'll write here. So the percentage multiplier is 100, the original, less 35. So that's equal to 65%. So what she gets for selling it is going to be 65% of the original amount. So 240 times 65%. So if you're happy doing that in your head, you can just write that down. Times 65%. Percentage sign is important. So £156 she gets for selling the tablet. Now let's just take a quick look. If I'd have forgotten to put that percent symbol in, I'd have had 240 times 65, which is 15,600. I would hope that if you do forget to put that in, you're looking at that answer and thinking, that can't be right. Something's gone wrong there. So it's important that you're looking. There's no way I'm expecting an answer of £15,600 if my answer should be less than 240. So then we come on to the new tablet. The new tablet, money Excuse me, I'm about to sneeze. Money she needs for new tablet. So the money she needs for the new tablet is 365, but there's a multiplier here that you can do in your head, but we'll write it down. Will be the 100% of the original, 20% off. So I need to multiply that by 80%. So 365 times 80%, £292. Does that answer the question? Let's just check. How much extra will Gemma have to pay towards the new tablet using the special offer? Well, I haven't answered that yet. So in order to do that, so Gemma will need an extra, and we're looking at the difference between what she needs to buy it and what she made from selling the previous one. So 292 take away 156, £136 more she needs to find. So that earns you 8 marks, because the additional 2 for organisation and communication is this. Don't have to write a story, you're just writing a brief explanation for each line of maths that you're using. And then these parts, the percentage multiplier, if that helps you, write it down. If it doesn't, if you can do that in your head, then by all means do it in your head. Question 2. Jane and Thomas own a sandwich business. They decide to price sandwiches individually each morning. At 3 p.m, any unsold sandwiches are reduced by 45%. So it's another one that's coming down in value. Any sandwiches still unsold by 4:30 are reduced by a further 20%. Jane says, why not reduce sandwiches by 65%, which is adding those two together, at 4:30? It works out the same. Tom disagrees with Jane. Using multipliers, show that Jane is incorrect. So what we have to do here is first of all work with the 2-stage reduction, then work with the 1-stage reduction and show that they are different. What's difficult with this for lots of students is that they don't give you an original price to work with. So what you need to do to kick things off is to say, I'm going to work with a sandwich that's a certain cost, whether it's £2, £3, it really doesn't matter as long as you stick with that price. So if a sandwich costs, let's go for £2. So first of all, at 3 p.m, it will cost £2 times, and then the multiplier is going to be 100% less 45%, which is 55%. So this time I'm just going to write that down. So 2 times 55%, £1.10. So that's how much it will cost after 3 p.m. And then after 4:30, that is reduced by a further 20%. So at 4:30, it costs £1.10 That's been reduced by 20%, so 100 minus 20 is 80%. So £1.10 is still on my calculator, times 80%, 88 pence. So using their current system, an unsold sandwich costs 88 pence after 2 reductions. Now that same sandwich with 165% reduction will cost, so the same sandwich with 165% reduction will cost £2 times, so 100 less 65, so 100 less 65 is 35% of the original amount. So 2 times 35% equals 70 pence. So it is not the same. Jane is incorrect. If those two were the same value, Jane would be right. Prices are different. So if I circle those, so Jane is incorrect. So where students find that question really difficult to answer or access is because it doesn't give them a starting price. When that happens, just make one up. So those are 2 GCSE examples of percentage increase and decrease. You're looking there at grade D really level percentage work. What we're going to move on to now is how we can use percentage multipliers to easily solve grade B percentage questions. So what we call these are reverse percentages, and we'll see why as we work through. So at intermediate tier, you need to look carefully at the information in a question to see if you're being asked to find an increase-decrease value, like those previous questions, or they're still talking about a percentage increase and decrease, but you're actually being asked to find the original amount. You need to spot this, and the easiest way to spot it is where the question appears on an intermediate tier paper. If it's in the first half of the paper, then it's almost certainly a DE question like the previous ones. If it's in the second half of the paper and you're looking at it thinking that's too easy, well, it's almost certainly one of these reverse percentages. So you need to be looking for it, because if you just don't look for it and don't spot it, you throw marks away by oversimplifying the question. So let's take a look at a couple of questions like I mean. So in a sale, a pair of jeans has been reduced by 20%. Okay, at that point, looks no different to the previous questions. If the sale price was £64, how much were the jeans to buy before the sale? That's the trigger. Okay, they're asking you for the original amount, the amount before the reduction happened. So a percent multiplier, let's put that in, will be 100%. It's a reduction of 20%. So I'm working with 80% of the original value. If I put that in a number machine, I've got the original cost going in. I'm going to multiply that by 80%, and that gives me the reduced price. So that's my number machine. Original cost in, it's been reduced, so the reduced value is 80% of the original price. Now in this question, it's not the original that we're given. We're given the reduced price. So we have to go backwards with our maths to go from the output of the number machine to the input. And what you will have learnt back in Key Stage 3 with these number machines is that if we have to travel in the opposite direction, you do the opposite operator to going in the original direction. So we're doing the opposite of multiplying by 80%, which is dividing by 80%, because we're reversing the process. So the original cost will just be £64 divided by 80, and remember the percent, I haven't written it down there. So we have to do 64 now divided by 80%. So the original cost was £80. By far the most common wrong way of dealing with that is that what people do is they find 20% of the reduced price and then take that off. And that doesn't work, because 20% of that value is different to 20% of the original value. 20% of that is different to 20% of that. So once you go hunting for it, it's a really straightforward B grade question, because you know it's a B grade question. It ain't as obvious as you think. You're looking for before. It's a reverse percentage question, but there's not a lot of learning there. It's a quick win. And the same thing happens with increase. So this time I've got a 3% pay rise. Pay rise means your money's going up. Sally was earning 46,350 a year. How much was she earning before the increase? That should really be better if it says, so that's my bad wording there, following a 3% pay rise, Sally is now earning 46,350. How much was she earning before the pay rise? Well, let's write our multiplier down, although if you want to, you can just do it in your head. It's a pay rise, so we're moving from 100% to an additional 3. So into my number machine goes the original earnings. We're going to multiply that by 103%, and out comes that after her pay rise. So following her pay rise. Here's the trigger. How much was she earning before the increase? So this is her following pay rise. So I'm traveling backwards through my number line, which means I'm not going to be multiplying by 103%. I'm going to be dividing by it. So I'm going to do 46,350 divided by 103%. Remember, the percent is vital. £45,000. So she was earning £45,000. She had a 3% pay rise, which took her earnings to 46,350. Now, both of those examples, I've written what the multiplier is. I've drawn a little diagram to show how we're reversing it, but all you really need to write is the bottom lines. If you can spot and say, right, well, it's 80%, but I'm going backwards, so I'm dividing, that is all you need to write for the marks. So let's take a look at a past paper example of that. Television was reduced in the sale by 26% of its original price. It cost Marta £710.40 in the sale. What was the original price? So that would have cropped up second half of the paper. I'd have looked at it and think, that's not as straightforward as it looks. It's a grade B. I'm looking for the original. So let's just do this in one line. £710.40. I know it's a reverse, so I know I'm going to be dividing by the percent multiplier, and all I have to do is work out what 100 less 26% is, which is 74%, because it's being reduced by 26%, and work that out. Typed it exactly as I see it, 960 quid. Easy as that. So that's reverse percentages. The other grade B topic is compound percentages. Now, sometimes these can be grade C, but they're appearing now on numeracy papers in slightly more complicated ways. If a quantity is being repeatedly increased or decreased over time, for example, money earning interest payments in a bank account, or a car losing value as it gets older, then the percent multiplier is raised by the power of the time period. That sounds complicated, but it isn't, and I'll show you why that is here. So a bank pays 1.8% a year, PA, interest on its savings accounts. If I pay £10,000 into the account, how much will it be worth in 8 years? So what you do here, let's get our percent multiplier. That's going to be your original amount. When you pay interest, it means it's adding money into your bank account. So 1.8% means that at the end of the year, once they've paid me, I'm going to have 101.8% of what I started with. So for 1 year, I start with 10,000 and I'm going to multiply it by 101.8. If that's 2 years, I'm going to take that and I'm going to multiply it by 101.8. In the third year, fourth year, fifth year, sixth, seventh, eighth. So I'm going to multiply it by my percent multiplier 1, 2, 3, 4, 5, 6, 7, 8 times, which is a bit of a pain. And if that was over 25 years, as some savings accounts are, then that would be a real pain to do. But we don't have to do that, because you should recognize or remember from your maths work, your algebra work, that if you're multiplying something by itself, so for example, if we were doing 3 times 3, we could write that as 3 with a little power 2, 3 squared. if we were multiplying it by itself 3 times. 3 times 3 times 3 would be to the power of 3. So rather than have to write this, I'm multiplying by 101.8 8 times. So that's a power of 8. The most common mistake people make is they say, well, let's just do it once and multiply by 8. But that would be if we were adding 101 8 times. When we're multiplying by itself, repeated multiplication, it's a power. So rather than doing that, what I'm going to do is 10,000, the original amount, times 101.8%. All of those should have been percents. To the power of 8. So let's put that into our calculator exactly as I've written it. 10,000 times, open bracket, 101.8%, close bracket, and then for the power, it's this button here, X, with a little square floating above it. If it was just squaring, it's got its own button. If it was cubing, it's got its own button. But any other power that you need to enter yourself, you press that one, and then we'll put a little 8 in there. Press equals, and that tells you that after 8 years, what you have in your bank account is £11,534, and to the nearest penny will take us to the next 2, 0, 6, and it's a 6 because the next digit along is less than 5. So that's what you're doing, but you're not going to do it that way. You're going to use this powered multiplier method. So here, this concept of the multiplier unlocks just one line of maths. In the same way, the power of the multiplier there also unlocks a one-line maths solution. So it's a really, really good way to think about increasing or decreasing percentages. A new car loses 19% of its value during the first year and 5% per year thereafter. Calculate the value of a car after 10 years that cost £30,000 when new. So we've got two multipliers here. We've got the first year multiplier, it's a loss, so I'm taking 19% off the 100%, which is 81%. And then every other year it's a 5% reduction. So that would be 100 less 5 is 95%. So we're going to do this in one line of maths. The cost of the car multiplied by the first year, 81%. And just so you'll be able to see the balance when I finish writing the line, the number of years that that reduction happens is 1. It's only in the first year. And then every other year it's 95%. And because I'm interested in after 10 years, that means it's 1 year at that and 9 years at that. So those two add up to 10. One line of maths, all in one go on your calculator. 30,000 times, open bracket, 81%, close bracket, to the power of 1. Then to move that down, because it's floating up there, you then press the little cursor arrow, which is that there, to move it down, multiplied by open bracket, 95% to the power of 9. So it's typed in the calculator exactly as I've written it there. Press equals 15,315 pounds and once again 6 pence. So started being worth £30,000. After 10 years it's fallen to £15,315 and 6 pence. So those are compound changes, increases or decreases. And what usually you're looking for there is the trigger that it's being invested or it's over a period of time. So let's have a look at a few examples or actual GCSE questions, and let's see if we can get the clever one-liner maths going. So Caris decides to invest £380 in a savings account for 6 years. The account pays a rate of 2.54% annual interest, AER. Will Caris have sufficient money in her savings account to be able to buy a motor scooter costing £460 in 6 years' time? You must show all your work here and give a reason for your answer. So it's paying, so it's increasing what's in her account. She's going to start with that, and then every year 2.54% is going to be increasing. So my percent multiplier will be the original amount 100%. It's increasing, so it's plus 2.54. 102.54%. So you could have done that in your head, which would be fine. But if you're not sure or you just want to be careful, write that down. So here's the maths. 380 is in her account. It's being increased by that percentage for 6 years. So let's see what she's got in her account. £380 times 102.54% to the power of 6. 441 pounds 71. Look at the next one over. It's 5 or more, so that's going to be 72. So that's what she's got in her account after 6 years. So does that answer the question? Well, the question was, will Caris have sufficient money in her account to be able to buy a motor scooter costing £460 in 6 years' time? Well, that's how much she's got in her bank account in 6 years, so no, she doesn't. She is, and then we can work out the difference. So if we do 460 less 441.72, she's £18.28 short. Okay, a couple more to have a go at. The price of softwood changes each year. The price is increased by 6% per annum for each of the last 5 years. Before this, the price had decreased by 2% per annum. So I've got an increase of 6 for 5 years and a decrease of 2 before that. and I'm interested in 7 years ago. So 7 years ago, so my powers are going to need to add up to 7. 34 pound per cubic meter. So I've got two multipliers. I've got an increase multiplier. So if I say multiplier 1, multiplying number 1 will be 100 increase plus 6% is 106%. And then the other multiplier is a decrease of 2%. 100 is the original, decrease minus 2 is 98%. So I'm starting with 34. I'm going to be multiplying that by 106. I'm going to be multiplying it by 98%. What I've got to work out are what the powers are. So for the last 5 years, it's increased. So I've got 5 years of that, and before that it was decreasing at 2%. And I'm interested in 7 years ago. So if there's 5 years of that, it means there were 2 years of that. So 5 years of increase, 2 years of decrease. What's it worth now? 34 times 106% to the power of 5. Bring the cursor back down. Times 98% to the power 2. 5 and 2, 7. £43. 69. Next one over is one bigger, which is going to make that 70. So it's currently worth £43.70. And then the last example, numerical answers are there if you're doing this yourself. Marley's scooter depreciated, tells you that means decreased, by 24% in the first year, and in all further years the scooter depreciated by 13%. So let's do this one, just writing the whole thing down. So she originally paid 850. 24% reduction, so 100 less 24 is a 76%er. Then 13% was 87%. 7 years. So my powers need to add up to 7. In the first year it fell by 24%, and then all for the further years it fell by 13%. So after 7 years this must be 6. So it's 1 year at that drop, 6 years at that drop. So 850 76% to the power of 1, open bracket, 87% to the power of 6. So after 7 years it's going to be worth £280 and 12 pence. So that's a session where I'm hopefully giving you some confidence in going hunting for grade B percentage questions. Easy to learn, not a lot of steps to learn. It's more important that you go looking for them and you're recognizing that's a grade B reverse percentage because it's in the second half of the paper, or that's a grade B compound percentage because you have these complicated percentage multipliers repeated over a number of years.